This is page 102 of the Incredibles book. This is the bottom half. We did the top half already. We're doing the trigonometric derivatives. You're supposed to already know the derivative sine is cosine. Derivative cosine is negative sine. Now we're going to develop a couple of these, or these are the basic rules you're supposed to know. The derivative tangent is secant squared x. Derivative cotangent, negative cosecant squared x. Derivative secant is secant x times tangent x. Derivative cosecant is negative cosecant x cotangent x. I'm going to develop two of these. It says proofs, but this is not much of a proof. It is simply using the quotient rule. So, what is tangent x? All right, so tangent x. So if I have a function y equals tangent x, and I want the derivative of that, I'm going to rewrite it in terms of sine and cosine. So it's sine x over cosine x. Excuse me. Hope that didn't startle you. All right, so sorry, that should not have been a derivative symbol because I haven't taken a derivative yet. All I did was rewrite tangent as sine and cosine. Now I'm going to take the derivative. And this is a quotient, so I'm going to have to use the quotient rule. So you bring the denominator up times the derivative of the numerator, which is cosine x, minus derivative cosine, which is negative sine. So I'm going to do sine x and then change the sign, S-I-G-N. I change the minus sign to a plus because it's negative sign. So it's a minus a negative sign. So I change that to a plus. And then sine x all over cosine squared x. That's a cosine squared x. Now, rewrite this expression. This is cosine x times cosine x plus sine x times sine x. So right up here, it's cosine squared x plus sine squared x over cosine squared x. Right? Cosine squared x plus sine squared x, remember your trig identities, that's equal to 1. So that's 1 over cosine squared x. And 1 over cosine squared x is simply secant squared x. There's our derivative. All right, let's go on to this one here. Proving secant x. I'm going to just throw in another piece of paper. I've noticed that it's really not big enough. You can watch it and write it, whatever. Anyways, so I'm going to use y equals secant x. Rewrite it using sine and cosine. And now I'm going to use the quotient rule. So y prime equals cosine x, right? Quotient rule says bring up the denominator, times the derivative of the numerator. The numerator is 1. Derivative of 1 is 0. Minus derivative of the denominator, which is negative sine x times 1 over cosine squared x. And then we have, so that's 0. Minus and negative is plus, so it's positive sine x over cosine squared x. Now, continuing, we'll simplify that. And I'm going to do something weird here. I'm going to rewrite it as sine x over cosine x cosine x. All right? So I'm going to rewrite this again as 1 over cosine x times sine x over cosine x. And what's 1 over cosine x? That's secant x. And sine over cosine is tangent x. So I have shown you how the secant x, when you take a derivative, turns into secant x tangent x. That's that. All right, let's just do some examples here. What is a derivative of 3x minus secant x? Derivative of 3x is 3. Derivative of secant is secant x tangent x. And that's it. B, take the derivative of that. This requires the product rule. You have e to the x times tangent x. So I am going to keep the first one constant. Take the derivative of tangent, which is secant squared x, plus take the derivative of e to the x, which is e to the x, and keep the tangent constant. All right, I mean, don't change it. All right, let's change this into x's because this becomes very difficult to read. So we'll make that g of x equals x cosecant x. So g prime of x. So this requires the product rule because it's x times secant x. So x times the derivative of cosecant x, that's negative cosecant x cotan x plus derivative of x is 1. I want to write it for emphasis, times keeping the other one constant. So let's clean this up a little bit. It doesn't clean up much. Bring the negative forward and make a negative x cosecant x cotangent x plus cosecant x. All right, that's it. D, let's just use quotient rule. Quotient rule for this, you bring the e to the x up, right? Bring up the denominator times the derivative numerator. Derivative of secant x is secant x tangent x minus derivative of e to the x, which is e to the x, times the numerator, which is secant x, all over e to the x squared. E to the x squared, I want to work on that. In fact, I'm going to clean this up a little bit. I'm going to factor out e to the x secant x. So that's going to be e to the x times, I didn't do a good job. So e to the x secant x, and that'll be tangent x minus 1 over e to the 2x. Remember, whenever you raise things with exponents, with more exponents, you just multiply the exponents, and that can reduce. So that's just going to be secant x times tangent x minus 1 over secant x. Oops, not secant x, over e to the x. Right? I'm reducing e to the x and e to the 2x. That's it. That is the answer to D. And I think there's time to do the next one. By the way, I didn't do this in class because it was kind of boring. This is just take higher order derivatives. You take in multiple derivatives. So derivative of this is 12x cubed minus 15x squared minus 2. Second derivative, that means you're just taking it again. The notation is, so the first derivative is 1 apostrophe, second derivative is 2 apostrophe, and all that stuff is noted up here. 1 apostrophe, first derivative, 2 apostrophe, 2 derivative, second derivative, 3 apostrophe, third derivative, 4. Don't do 4 apostrophes. I guess you could, but what we do is put the number in parentheses. So this means the fourth derivative, and so on. Okay. Same with these. We use the same notation for f. For first derivative, it looks weird. Second derivative, we'll put the 2 on the d in the numerator, but on the x in the denominator, and that's where what it looks like exponents go. All right. Okay. And then here, so the second derivative, you just take the derivative again. So it's 36x squared minus 30x, and that's it. So this one, which is not very friendly, h prime of x, keep the x, take the derivative of e to the x, which is itself, plus derivative of x, which is 1, so it's e to the x. Second derivative, well, we know what the derivative of x e to the x is. It's x e to the x plus e to the x, and then take the derivative of e to the x, so it's plus e to the x. So this is the derivative of the first term, because we've done it before, and then e to the x is derivative of that. So you should clean this up to x e to the x plus 2e to the x. And C, or G. G prime of x, derivative of secant x is secant x tangent x. And G double prime of x is product rule. Let's keep the secant x constant, take the derivative of tangent x, which is secant squared x, plus derivative of secant x is secant x tangent x times tangent x. So this is secant cubed x plus secant x tangent squared x. Interesting. All right. And D. So y prime is 3 cosine x. And then y double prime, it changes signs. Cosine to sine. Right? The derivative of cosine is negative sign. That's where that negative sign comes from. SIGN negative. All right? That's it. That's all we did in class today.